Good morning to Madam Siti and all of the students. Today we are going to present Safety Interlock System SIS in Petrochemical Engineering. These are my group members. We have Danielson, Sri Ganesh, me, and Erica. And today we are going to present introduction, type of SIS, example, function and applications of SIS. So, to introduction of this SIS, in the case of many unsafe detected conditions, a safety instrumented system SIS is a collection of SIF designed to bring an industrial process to a safe state. In the case of specified dangerous circumstances, the SIF is one or more components that are allocated to perform a specific safety-related activity. A SIS is a collection of hardware and software controls that are specifically designed for critical process systems. Now, moving on to the types of SIS. So, the first one of the SIS is a rotary and hinge safety interlocks.
Type of SIS. Type of SIS. Rotary and hinge safety interlock. On the hinge side of an access door, rotary and hinge device are meant to be mounted. The international and Europe standard system refer to them as functional category 1 device. The actuator is an inherent element of the housing, making functioning category 1 safety interlock one-piece construction. There are no slot or nests in this device where dirt or other debris might gather and create the difficulty. They are also less likely to be exposed to airborne fuel, oil and mist because they are normally installed out of the way in the machine frame.
Now, we move on to the second SIS, which is Standard Mechanical Safety Interlocks. Standard Mechanical Safety Interlocks is a functional Category 2 device. As defined by international and European standards, it is one of the most popular forms of safety interlock. The safety interlocking housing plus a separate coded actuator make up a working Category 2 safety interlock. The actuator is normally attached to the gate when aligned with a slot in the housing that is attached to the structure. The safety connections close after the actuator is tightly nested into the housing, enabling the machine to run. When the gate opens, a mechanical motion known as positive opening forces the safety contacts open, sending a stop signal to the machine. For safety application usage, positive opening is essential. It assures direct mechanical action in opening the safety contacts and does not rely on springs to execute the safety function. The safety contacts are intended to break even if the contacts are soldered together. The safety contacts are intended to burst open even if the contacts are welded together, resulting in a stop signal. As an example, the mechanical safety interlock switches a movable guard door to the hazard power supply. The power is disconnected when the guard door is open, ensuring the machine does not pose a hazard when an operator needs an access.
Guard locking safety interlock. Guard locking devices have their actuator and employ a solenoid method to secure the engaged actuator. The solenoid not only detects whether the gate is open or closed, but also keeps it closed, restricting access to the machine until it determined that it is safe. These devices are beneficial for machines with extended stop periods and where accessing the machine during the process might cause material damage. A safety-rated stop-motion detection system or a safety timer is most likely the source of the control signal that unlocks the door. Spring locking and power locking are the two most prevalent locking types for guard locking system. Because the locked state does not require any external positive signal, spring locking is preferable for people guarding situations when there is no power to the solenoid. Second, to facilitate machine maintenance, lookout or tag out processes, spring locking device must provide a way to manually override the lock. Only authorized personnel should be able to use the override to attain the locked condition. The solenoid must be powered by an external control device before deploying power locking devices to protect employees. Think about various solenoid failure modes such as damaged wire, supply voltage failure, and failed solenoid coils.
Magnetic safety interlock. Safety interlocking may be an option when typical mechanical safety interlock do not meet application objectives due to environmental concerns, space constraints, or mechanical limitations. A sensor plus a magnetically coated actuator make up a magnetic safety interlock. Multiply magnetically actuated reed contacts are included within the sensor, and in order for the machines to function, they must match up with a specifically coded actuator. This magnetic coding is not only redundant in terms of design, but it also protects against bypassing the system with simple magnets. Magnet interlock are advantage because they are compact size, improve housing protections rating, and non-contact functioning. Example: essentially, safety instrument system monitors sound specifics, value sense parameters of an operating plant, and when optimal conditions rise, they issue an alert and place the unit in safe or even shutdown mode. A few safety instrument systems that are typical examples include: firstly, during over procedure conditions, the SIS on the high full gas pressure line take action to close the main gas valve. Second, when SIS detects a very high reactor temperatures, it takes action to open the cooling media valve to keep the system safe. When the SIS detects a high distillation column pressure, it takes action by opening a pressure vent valve. The thermocouples on a gas stove to prevent unburned gas from escaping if the gas is not ignited. Interlock sensor and actuator include a light curtains, a capture lever mechanism, and thermocouple.
Functions. One or more safety instrumented functions are implemented using an instrumented system. The sensor, logic solvers, and final pieces that make up a SIS can be a combination. Safety instrumented control functions, safety instrumented protection functions, or both can be included. Many industrial operations, particularly those in the chemical and oil and gas sectors, are highly dangerous owing to the presence of hazardous chemical gases. The next function is SIS are especially designed to safeguard employees equipment, and the environment by minimizing the chance of recognized emergency event occurring or the severity of its impact. The SIS other job is to keep an eye on process for potential unsafe situation, for example process demands, and to intervene when necessary to safeguard it.
So these are the applications. An interlock is employed in most applications to prevent a machine from injuring its operator or destroying itself by preventing one element from changing state owing to the condition of another element, and vice versa. Elevators have an interlock system that stops moving elevators from opening their doors and stationary elevators from moving. An interlock should not be mistaken with a basic safety switch, despite the fact that both are foolproof solutions. The switch that disables the magnetron if the door is open in a conventional family oven, for example, is not an interlock. Instead, if the door is secured while the magnetron is on and the magnetron is stopped from working when the door is open, it is termed an interlock. Interlocks can incorporate complex features like infrared beam safety curtains or basic safety gate switch and locks. So for the conclusions, safety is a critical component of any company, particularly in hazardous industries such as oil and gas and chemical manufacturing. In the workplace, a safety interlock system is essential. In terms of safety, it is anything that protects persons who are operating a process or piece of equipment from harm or death. That is all from our group. Thank you for listening.